Section 1.2, the law of the mean examples. We're going to do 3 different examples. The first example is actually a theorem. It's the uniqueness of differential equations. In elementary calculus, we have learned that a differential equation, once you solve for it, the answer is unique up to a constant. To put it another way, is that let f be differentiable on an opening interval ab, and let's say f prime is 0 on the entire interval. Then the function f has to be a constant. Now to prove this, the law of the mean works like a dream. What you do is you pick any 2 points in AB. So let's say we pick x1, x2 are the 2 different points in AB. They're different. So then f, the function of x1 minus f2, x2 by the law of the mean is equal to this relationship, which is equal to x1 minus x2 times f prime of something in between, psi, between x1 and x2. But that is going to be equal to 0 because f prime psi is 0 since f prime is 0 everywhere. So then that gives you that the two values, the function and the two values are the same. But those 2 points are random, which means the function value at any 2 given points are the same. And therefore, it proves the uniqueness of differential equations. And that's going to come in handy later. Now, the next problem we are going to solve is this is kind of an artificially made up thing right here that we will use it to demonstrate the power of the law of the mean, being able to solve certain weird inequalities. Now, to solve this particular to prove this inequality, which says log x over x must be less than log a over x plus 1 over a if a is between x and 0, and x is bigger than 0, of course, being that it's a log. So then, and remember, log means natural log only in advanced mathematics. So then let's prove it by pulling a trick and hope that everything comes out. So let's let the function f in the law of the mean, which we're going to apply, let f of x equal to log of x. Then, of course, f prime of x is going to be equal to 1 over x by simple differentiation. Now to do, and now we're going to apply law of the mean, and which says that on f, on x, and on a, because we have only 2 things. So then the law of the mean states that f of x, which is log x, okay, minus f of a, which is log of a, equal to x minus a, all right, times f prime of x over f prime of something, okay, some psi, where psi is in between a and x, like this. So that's the law of the mean. Now, so far we have gone here. This doesn't quite look like that because there's a denominator here. So what we're going to do is simply divide by the denominator and make everything look kind of like that. So we're driving towards our goal. And so let's divide everything by x for no reason other than it's there. So if we divide everything by x, we have log x over x. Okay, x is bigger than 0 in our consideration, so we don't have to worry about dividing by 0. And then equal to log a, also divided by x, plus x minus a divided by x times 1 over psi. All right, so that's that. And now this particular equation is very similar to the inequality, and we have to show that this thing is less than 1 over a, because if it is, then we're done. So how do we show this thing has to be less than 1 over a? What we do is do a bunch of tricks like this. So x minus a over, this is what we are looking for, okay? X times 1 over psi. What is that? That is less than or equal, this thing right here, okay? This particular fraction is less than 1. There's no equal to here. Okay, because everything is strict inequality. So this thing is less than 1 because a is less than x, as we have required originally. So this fraction has to be less than 1. So in other words, this, and being that everything is positive, then this whole thing is going to be less than 1 over psi. Okay, and what is psi? Psi is in between a and x. Psi is bigger than a, therefore 1 over psi is going to be less than 1 over a. And that's what we're trying to prove. This chunk right here is less than 1 over a, therefore this inequality holds. It's kind of a cheap trick, but the law of the mean is good for this kind of stuff. And that's not particularly useful in the long term, but the next example we look at will be actually useful. Here's a relationship we have to prove. 1 plus h to the power alpha is bigger than 1 plus alpha times h, where in this situation h is positive and alpha has to be bigger than 1. Now this is much harder to prove if you just look at it because that power could be 1.5 or something. So this is where the law of the mean comes in very handy. To prove this particular relationship, which we will use later, so it's a good idea if you try to memorize this if possible. So then we will use the law of the mean again. The law of the mean is stated right here. But to do this, we'll write it in a different form, like this. This is a different form of law of mean. We will put the 2x, we'll call x1 as a plus h, and x2 as simply a. So their difference is h. Plus, okay, as I mentioned, x1 minus x2, that should be a 2 there. x1 minus x2 is simply h. Okay, so it's the same form times f prime of something between, this side is between a plus h and a. So we'll call it a plus theta h, where theta is a value between 0 and 1. So as you can see, this is exactly the same thing as that, just written down a different way. So then this thing right here is the same as psi. All right. And the reason we want to write it this way is because this looks a lot closer to that. And that will make it easier for everything to come out very nicely. So define our function f to prove this. Let f equal to x to the power alpha. And remember, alpha is bigger than 1. So of course, well, that isn't all the way of writing. Let me write better. Let f of x equal to x to the power alpha. So then, of course, f prime of x is alpha f prime of x, I'll just write it right here. Prime of x is equal to alpha x alpha minus 1. Okay, standard differentiation equation. And then we will plug this whole thing in right here. So f of a plus h, by the way, we'll choose a equal to 1, is equal to 1 plus h to the power alpha, that thing right here, because we set a equal to 1, okay, for this equation. So f a plus h is 1 plus h to the power alpha, which according to the law of the mean equation is equal to f of a, which is 1 times the power alpha, plus h times f prime. And f prime, as we have right here, is alpha x alpha minus 1. And the thing inside is a plus theta h, which is 1 plus theta times h. All right, so that is the law of the mean. Now, right now, we have this thing, okay, which is the same as the original, and 1, that's just 1. And this is also the same here. So the only thing we need to show is this thing has to be bigger than 1. I mean, this thing has to be bigger than 1. To show that, we can see that 1 plus theta h alpha minus 1. What is it? Now, theta is bigger than 0. H is bigger than 0. Okay, theta bigger than 0, h bigger than 0, and alpha is bigger than 1. So all of that add up to be one thing. This is going to be bigger than 1 because theta is bigger than 0, h is bigger than 0, and alpha is bigger than 1. So this is bigger than 1, which means that whole thing is going to be bigger than this. And that concludes our proof.